This is Dominica with Easynomics, and this will likely be the final part of a paper 2 dissection regarding wheat prices and the impact of the Russian-Ukrainian war. In the video notes, there are links to these videos that I've been using in this video series, looking at wheat prices and the concern that the rising wheat price, due to the supply shock of the Russian-Ukrainian war, restricting wheat into the global market, could lead to a potential food crisis causing riots, famine, etc. Again, this article highlights that concern, and that could lead to mass migration in the region of the Middle East and North Africa. And this article provides a look at a particular country and the impact of this within Egypt. In the previous videos, we've looked at the rapid rise in the price of wheat from $277 per ton in February 2022 to rising to $523 in March of that same year, a rapid increase in the price. And below, within the text, we can see that the Egyptian government spends about $3 billion annually on wheat imports, which could rise to $5.7 billion due to the higher price, and how that's going to impact Egypt's Baladi bread subsidy program, which provides 150 loaves of subsidized bread per month to millions of people within the population. 90% of that is cost that is carried by the government, currently spending $324 billion, but that number will rise close to maybe $6 billion because of the higher wheat input price. In the top corner, I will have links to these previous videos that looks at the elasticity of the demand curve for wheat, its supply curve, the impact of a supply shock, and for higher level students, utilizing a perfectly competitive market structure to illustrate that. Okay, so here we have a series of paper 2 questions that we've already dissected, and now we're going to look at this last question, E, using a subsidy model, illustrate the market for bread in Egypt, explain the impact of the government intervention on price, quantity, and also discuss consumer and producer surplus and allocative efficiency. The final question of paper 2 will go over kind of an evaluation where you might be potentially providing solutions, evaluating those solutions, and so on. That might be something I'll discuss in a later video, but you can already see some potential solutions to this. So let's go ahead and graph this. So that question requires that we provide a model, subsidy model. So I've labeled this graph F to distinguish it from the previous graphs I've drawn for this paper 2. It will be the market for Baladi bread in Egypt. I'm measuring price on the y-axis, the quantity, supply and demand for bread on the x-axis. Again, I have some mental notes that I could include in my analysis. The objective here is to subsidize food as a necessity to make it more affordable to low-income households. Currently, the Egyptian government is spending $3 billion, but because the price of wheat, which is the input for bread, is rising from $277 per ton to $523 per ton, the government spending could increase to $5.7 billion. Currently, the Egyptian government is spending $3.24 billion on the Baladi bread subsidy program, but of course that can double, and we can imagine the opportunity cost to the Egyptian government of spending double the amount on bread as opposed to other social services within Egyptian society. So we'll have an upward sloping supply curve, which we'll label S1, and that's equal to our marginal costs of production. We're going to have a downward sloping demand curve, and I'm going to intentionally make it a little bit more inelastic because we are aware that bread is a necessity. Thus, by definition, it should have a PED less than 1. So demand equals marginal benefit. And we're in the free market, so that provides a free market price equilibrium. Let me use a straighter line here at P1, and equilibrium quantity at Q1. Price at P1, quantity in the free market at Q1. Now this price of P1 may be deemed too high for low-income households to afford. So the Egyptian government steps in with their per-unit subsidy program. And subsidies are a non-price determinant of supply. It causes the supply curve to shift outward. You can imagine it shifting outward by the amount of the subsidy, or you can also imagine it as shifting downward because it's reducing the costs of production for the producer. So it shifts out from S1 to S2. Okay, so here we have S2. We're going to label it as being equal to S1 minus the value of the per unit subsidy. S2 is equal to S1 minus the subsidy. So the distance between S1 and S2 is the value of the subsidy for each unit of Baladi bread produced. We notice here it creates another intersection, and that will signal the price paid by the consumer. So let's go ahead and label that. Here's our new intersection. So the quantity, supply, and demand, it increases from Q1 to Q2. And the price paid by the consumer falls from P1 to, I'll label this PC, price paid by the consumer. And the distance between the price paid by the consumer and the supply curve for the firm is the value of the subsidy, and that will become the price received by the producer. So I'm going to label this price received by the producer, and then I'm essentially done. So I'm going to label some points. This could be labeled point A, point B, and point C. You can imagine that the firm is really operating along S1, and they will increase their quantity supply along their supply curve from point A to point B. And at point B, they will stop, and then they will subtract the subsidy so that they can offer their product at a lower price to consumers, incentivized to lower their price because they know as they lower their price, it will increase the quantity of demand. They will be able to sell their excess of bread, and that meets the objective of the government of using the subsidy to cover the cost of production and to lower the price paid for by consumers. Now I'm going to go ahead and label some additional areas so that I can discuss the change on allocative efficiency, consumer and producer surplus, etc. So let's use this brown color. This area here, I'll label this A, B, C, D, lowercase, to distinguish it from the uppercase capital ABC, A, B, C, D, E, F, G, and H. All right, and now I'm done. I've fully labeled this. So let's go ahead and analyze this model as we would for a paper exam for the IB. As can be seen in graph F, we're illustrating the market for Baladi bread in Egypt. We're measuring the price of bread on the y-axis, the quantity of bread on the x-axis. We have two upward sloping supply curves according to the law of supply, labeled S1, which is equal to our marginal costs of production, and S2, which is equal to S1 minus the subsidy. We also have a downward sloping demand curve labeled D1 equal to the marginal benefit. We can note that the demand curve is inelastic, that the PED value for a Baladi bread as a necessity is less than 1. We have an initial equilibrium set where S1 equals D1. That provides a free market price at P1 and a free market quantity at Q1, where quantity supplied equals quantity demanded. But this price may be deemed too high for low-income households to afford. So the government steps in and provides a per unit subsidy, which has the effect of shifting the supply curve outward by the amount of the subsidy, or also can be thought of as being shifted downward by the amount of the subsidy. That sets a new equilibrium where S2 equals D1, and the price paid for by households now decreases to PC with an increase in the quantity supply and demanded at Q2. So we see households are paying a lower price. It falls from P1 to PC, but we also notice that the price received by the producer increases from P1 to price paid by producer. All right, so the subsidy has the objective of increasing output and lowering price for the household, while also incentivizing Baladi bread producers to increase their output from point A to point B, because for each additional unit that they produce, they get a fixed amount of subsidized money, which covers their cost of production, which enables them to reduce their price to the household. Price paid by the household is at PC, plus the subsidy becomes the price received by the producer. So there I've analyzed the model, and now I can talk about changes in consumer and producer surplus. So consumer surplus before, I'll put it before the subsidy, was equal to areas A plus B. Area A plus B becomes the consumer surplus, the price paid by the consumer versus what they're willing and able to spend. But then consumer surplus changes and increases with the subsidy. After the subsidy is applied, it increases to areas A plus B, AB plus GFE plus G plus F plus E. So let's go ahead and illustrate that. All right. So even though this goes all the way up, I'll just draw like this. Originally, the consumer surplus was this area, and then because they receive a lower price, it increases to this area. The price they paid versus what they're willing to pay. All right, maybe I should go ahead and draw that like this so it becomes a little bit clearer. Okay, how about the producer surplus? Little note here. Oops. Producer surplus before the subsidy was equal to areas H and G. So I'll put G plus H. Producer surplus after the subsidy increases because they get a higher price to areas B plus C plus G plus H. So let me go ahead and illustrate that. Originally, it was this area here, G and H. The price received by the producer versus their marginal cost. And now the price received has increased. And we compare that to their marginal cost, and that becomes their producer surplus, which is now that area. It has increased. What about the subsidy? What's the value of the subsidy? The subsidy is equal to, the per unit subsidy is equal to areas B plus C plus D plus E plus F plus G, which is also equal to the price received by the producer minus the price paid for by the consumer multiplied by Q2, right? Or Q2, I can label that also Q sub if I wanted to. What does that area look like? Let's go ahead and illustrate that. This is the value of the subsidy. This is the amount of money the government's paying for each unit, price received by the producer minus the price paid for by the consumer, multiplied by the number of units produced. So it becomes this rectangular area here. All right, B, C, D, E, F, G. That is the amount of money that the government is spending. And before the Ukrainian crisis, the subsidy was costing 324 billion. So this area, B, C, D, E, F, G, H, or P minus PC times Q2 is equal to, before the Russian Ukrainian War, 3.24 billion which will increase with the higher wheat prices. All right. So there I've discussed the subsidy. What about the welfare loss? The welfare loss is equal to, let me use a different point. Welfare loss is equal to area D. Why? Because we see at area D, at Q2, the marginal cost of production is greater than the marginal benefit. All right, so right here I can mark point B, the marginal cost of production, and here's our demand curve, marginal benefit, right, is greater than the marginal benefit. So that is an over allocation of resources to the production consumption of wheat. But we can say that this is a positive externality. It reduces hunger, food poverty within the nation. So we could deem it relatively allocatively efficient. So there I've covered all the main points for that particular question. And then I can go on to discuss how that subsidized amount could potentially increase because of the rising wheat prices from 277 per ton to 523 per ton. So that's going to be an excessive burden to the Egyptian government. More government spending could increase their public debt, if there's an existing public debt, their budget deficit spending, and so on. And it also creates opportunity costs. The additional $3 billion they're spending could have been used for other public services. All right. So if you have any questions, feel free to comment those questions below, and don't forget to subscribe and to like. Thank you so much.